Have you ever found an old, unopened letter? You know, something from decades ago that just got lost in the mail?
Oh, yeah, a little time capsule. It's a great feeling.
Right. Now, what if that was on a cosmic scale? An epic message from a star that exploded 11,000 years ago.
Uh-huh.
And when the news finally arrived here on Earth in the 1600s, we just completely missed it.
That is the perfect way to describe Cassiopeia A, or Cass A for short. It's this ghost of a supernova.
So for this deep dive, that's our mission, right? To figure out how science became a sort of cosmic detective agency to solve a centuries-old mystery.
Exactly. And Cass A is just immense. We're talking about an expanding cloud of material that's about 10 light years across.
10 light years. That's
Yeah.
huge. And it's still the brightest thing we can see in the radio sky, isn't it? Above a certain frequency.
It is the brightest extrasolar radio source above 1 gigahertz, which makes the fact that we missed its grand debut in probably 1667 all the more baffling.
So how does that happen? I mean, that's the 1660s. People like Isaac Newton are actively charting the heavens. How do they miss a whole supernova?
Well, a couple of things were working against them. First, there's a lot of interstellar dust between us and Cass A, and that just soaked up a ton of the visible light.
Like cosmic fog.
Precisely. And second, the star itself was a bit unusual. We think it was a Type I Bub supernova,
Meaning?
meaning it was a massive star that had already sort of blown off its outer hydrogen layers before the final big collapse. That process really dims the main event.
So the few historical breadcrumbs we have, like an astronomer named John Flamsteed maybe cataloging a faint star there,
Yeah.
it's all just whispers.
Just whispers. The real discovery had to wait for us to develop a whole new sense. We had to learn how to listen to the universe, not just look at it.
And that happened in 1948.
Yep. Martin Ryle and Francis Graham Smith pointed a radio telescope at the sky and found one of the very first discrete radio sources. They found Cass A.
And even now we're still listening. We know that bright radio shell is, what, slowly cooling?
It is, yeah. It's losing about 1% of its intensity every year.
You know, this whole process of piecing together such a complex system from different signals, it really speaks to the value of deep analysis.
It really is.
And if you need help uncovering where new technologies like AI could make an impact for your business, whether for training, automation, or software development, check out Embersilk at embersilk.com for all your AI needs.
So after that first radio signal, the next big piece of the puzzle came from X-rays.
Right, in 1999 with the Chandra X-ray Observatory.
Exactly. Chandra peered into the heart of that expanding cloud, and it found it, the thing that started it all. CXOU G232E2327.8 plus 584842.
Which is a bit of a mouthful.
It is. It's the neutron star, the ultra-dense corpse of the star that exploded.
And that explosion was incredibly violent. The shell is still 30 million Kelvin and moving at, what, up to 6,000 kilometers a second?
At least. But it gets even more interesting. It wasn't a nice, neat, symmetrical explosion. Some knots of material are flying outwards at almost 15,000 kilometers per second.
So it was a lopsided blast.
Very lopsided. Supernovae are messy, chaotic events.
Yeah.
But the real aha moment, the thing that let us truly reconstruct the past, was just ingenious.
A light echoes?
The light echoes. In 2005, the Spitzer Space Telescope saw something amazing. It saw the original light from the 17th century explosion, bouncing off nearby dust clouds. It was like the universe had recorded the event for us, and the light was just now arriving from a different direction, a cosmic time machine.
And by studying the spectrum of that echo, we could finally prove it was a Type I explosion. It's like solving a murder with a reflection seen centuries later.
I love that analogy. And that same ingenuity connects this cosmic event directly back to us, to life.
You're talking about the elements it created.
The
then.
elements.
Yeah.
In 2013, we detected phosphorus in the remnant.
Which is essential for DNA, for life.
For all life as we know it. We confirmed that these explosions are where these crucial elements are forged. The amount of phosphorus there is like 100 times higher than the Milky Way average. These aren't just acts of destruction, they're acts of creation.
Cass A is really the perfect story of scientific progress then. We missed the main show, but with radio, X-rays, and these incredible light echoes, we pieced it all together.
We did. We figured out the physics, and we confirmed that these cosmic foundries are seeding the universe with the very stuff we're made of.
That 10 light-year wide cloud is still expanding, carrying all those life-giving elements out into the galaxy.
It is. And it makes you wonder, if our technology can rewind time using faint, scattered light, what other incredible phenomena are out there just waiting for our next big idea, our next tool to reveal themselves?
A fantastic thought. If you enjoyed this deep dive, please subscribe to the show. Hey, leave us a 5-star review if you can. It really does help get the word out. Thanks for tuning in.